So what I have discussed in the last class, can anyone tell me? Yes? Tell me. Can you hear me?
Imputation.
Imputation. Then
Imputation.
outlier
Imputation.
imputation, outlier detection.
Yes, sir.
Outlier detection like IQR and Z score we have discussed. Yes or no?
Yes, sir. Yes, sir.
So today we will discuss Python for data science, I think. Then we'll go for uh, Python. Today, Python for data science and roadmap to be discussed. Next class, EDA. Okay. In EDA, normalization, standardization, you after that means next class project discussion if possible. Okay. Getting it?
Yes, sir.
So uh, life cycle, data processing, imputation, Z score up to Z score and your IQR were done, right?
Yes, sir.
Hmm. Okay, can you see my screen now?
Not visible, sir.
No, sir. It's not visible.
Yes, can understand.
No, sir.
Hmm. Can you see my screen now?
Yes, sir.
No, it's
Hmm.
visible now, sir.
Okay. When you are talking about Python required for data science, okay, let me explain you in overally what are the stops we discussed. In the roadmap, you can understand everything. What are the stops that required, what you need to do. So means Python is one of the most widely used programming languages for data science due to its simplicity, vast libraries, and strong community support. And it helps in data manipulation, visualization, machine learning algorithms, and deep learning algorithms implementation. Yes, yes, right. Means first to set up the Python, first you need to install NumPy, Pandas, Matplotlib, everything. NumPy we are using for numerical computing and arrays. Pandas we are using for data manipulation and analysis. We are using Matplotlib for data visualizations. We are using Seaborn for statistical data visualizations. And Matplotlib and Seaborn, the differences in Seaborn we are using some advanced statistical visualization, and Matplotlib some simple visualizations. We can. Then we are using scikit-learn for machine learning algorithms training testing, and we are using what is that? SciPy for scientific computing. Okay. When it comes to Python for data science, data handling with pandas is important. How to handle your data using pandas? Can anyone tell me? Yes. How to read a data set? How to import pandas? Huh.
So import pandas as PD.
Hmm.
Imports pandas dot pd and
And
Then
the
PD dot
df
read
equal to pd
PD
dot
dot
read underscore
CSV
c.
and then the CSV file is name.
file name.
Yeah.
But only if you are working using
suppose
the notebook and all.
if you want to use past 5 rows, if you want to visualize it, what to write?
df dot head.
Getting it? Then to check the dataset shape, what we are using?
df dot shape.
Yeah. To check the column names, get the column names.
df dot columns.
Then means summary statistics. For a description, summary statistics. Describe. For finding check, is there any missing values or not? We are using what?
Is null. Dot sum.
Then for data cleaning and pre-processing, means before analysis, data must be cleaned and formatted properly. And to handle the missing values, we may use. I told you to handle the missing values. I have already discussed imputation, all of those stuffs. No. Is yes or no, guys?
Yes, sir.
Then tell me na. If any we found any means missing values, then what to do? Tell me. I've discussed along with you, all of you.
Using 5 number. No.
Tell me, bhai.
Sir, imputation use करेंगे.
Which imputation? Tell me.
Sir, mean median.
Sorry, guys. So we may use, if we found any missing values in the data set, we may use mean median mode imputation method. Fill na df dot mean in place is equal to 2, and we may drop the missing values. How to drop the missing value? How to drop the missing value? Suppose you want to fill, where you can use fill na. Then df dot mean, then in place is equal to 2. And to drop df dot drop in, right? And in place is equal to 2. Right, everyone? And
Right,
how
sir.
to handle the duplicate data? Means df dot drop duplicate in place true. Then how to handle the categorical data? pd dot get dominance. Okay. Then we are using Python for data visualization with matplotlib and cboard. What? How to visualize it? So means for normal visualization we are using matplotlib, and for histogram and for box plot we are using your what, cboard, right? How to visualize it, you all know. First import matplotlib as plt, then give x and y axis in the data set. Suppose means you want to create your own data set, then plot xy marker, then x level, y level, title, then plt dot show. Simple, right? Matplotlib, using matplotlib. Yes or no?
Right.
Hmm.
Yes, sir.
Yeah, means you can import matplotlib as, sorry, matplotlib dot pyplot as plt, then you can give x-axis, then y, then you can plt dot plot xy. The data set needs to be given and marker. Suppose then we can give dot x label your x axis to be considered, then dot y label y axis to be considered, and PLT dot title we need to give, suppose line plot, then PLT dot right. Suppose we'll give the data set as 1, 2, 3, 4, 5. In y axis we give 10, 20, 30, 30, 40. Yes. How to
Yes, sir.
how to plot a histogram plot? Import C1 as SNS, then SNS dot heat plot, histogram plot. Your value needs to be given, then beans and KD given. And for outlier detection, that we are using box plot, SNS dot box plot. Then for data analysis and feature engineering, we are using EDA, like your correlation analysis. Just a second. Just a second, guys. Am I audible?
Yes, sir.
Guys, I was not audible previously.
Now you are audible, sir.
अरे भाई उस टाइम बोलना चाहिए था ना, मैं वो स्क्रीन शेयर तो है ना. Okay. How are importing logistic regression when it comes to, I think you all know, when it comes to data analysis and feature engineering, what is correlation analysis, map, feature scaling, we are using standard scalar normalization, and Python we are using in machine learning with scikit-learn. Okay, means scikit-learn provides easy to use machine learning models, means fast splitting the data into train and test set, means from a scalar.model selection we are importing train test plate and we are dropping, then we are doing this train test plate, x train x test, y train y test, train test plate x y test size we are giving 0.2. Okay, and this is how we are applying roughly how we are applying logistic regression in machine learning. This way, linear regression, multiple linear regression, polynomial regression, all those stuff needs to be performed. Okay, then some of the advanced machine learning algorithms like random forest classifier we are using. Okay, for hyperparameter tuning with grid search. Okay, we'll be discussing the hyperparameter tuning in the upcoming sessions that I told you before. Where we are discussing, yes, yeah, optimization gradient descent, then we are using hyperparameter tuning, right? I think, yeah, it's okay. Inside grid search, all those stuff we are using. Okay, getting it, everyone? I think all of you, am I audible?
Yes, sir.
Yes, sir.
Yeah. This stuff to be come forward to this month, means your optimization and all, then your supervised learning, all those stuff comes to this, right? Because hyperparameter tuning is advanced topic. Okay, matplotlib, data visualization, mm, all those stuff we have already well complete. Data analysis, visualization. Okay. Mm, yeah. Cross validation. Then the mathematics. Getting it, everyone? If not possible, then mathematics to be discussed, because data analysis, visualization, matplotlib, C1, all those stuffs I've been discussing. We are discussing right now. Then supervised learning in the third week. Then your bias theorem, probabilistic, all those stuffs. In after that, unsupervised learning like clustering. Yeah, if possible, after supervised, unsupervised to be discussed fast or not. Okay, don't worry. Yes. So having said that, yeah. So some advanced machine learning algorithms. Am I audible to everyone? Audible, audible.
Yes, sir.
Yes, sir.
So then some model evaluation matrices like I told you what is precision, recall, F1 score, all those stuff we have discussed or not. Precision, recall, F1 score, root mean squared error, mean absolute error, mean squared error, all those stuff we have discussed.
No, sir.
No? All of you?
No, sir.
Okay. Listen. When I'm talking about, so let me complete this, then we are using Python for saving and deployment of the models. Then we are using a deployment using Flask. Then means Python provides what extensive ecosystem for data science that covering the data manipulation, visualization, machine learning, deployment. Means by mastering the pandas, numpy, matplotlib, and cbol, you can efficiently analyze the data and build the powerful models. Okay. Then when it comes to what you yes your confusion matrix. Then what is precision? What is recall? What is F1 score? Who can tell me fast? Quick, quick. What is precision? What is true positive? First, tell me. What is true positive, true negative, false positive, and false negative? Then we'll discuss what is all those terms. Tell me, quick. Do it. Hmm. Can anyone tell me?
Am I audible?
You are audible.
Actually, confusion matrix is mainly used in classification algorithm to evaluate the performance of algorithm by showing the n number of correctly classified data and number of wrongly classified data. Well, it is a confusion matrix, is a 2D matrix, like true positive, false positive, false negative, true negative. So this is the confusion matrix. So what is precision? Precision is used to measure of how accurate a model's positive predictions are.
What is recall?
Recall is nothing but a ratio of number of true positive and sum of true positive and false negative.
Okay, what is recall? What is F1 score?
Well, F1 score is used to evaluate the overall performance of classification models, sir. Well, it's also a harmonic mean of precision and recall.
Okay. Then tell me, what is support?
Suppose
What is root mean squared error?
no idea.
What is mean absolute error?
No idea, sir.
No. Okay. Then what is mean squared error, R2 score, all those stuff you don't know? What is standard deviation? What is standard deviation? Anyone over here who can tell me what is standard deviation? Can anyone tell me what is standard deviation?
Actually, I think it's square root of variance.
What is then root mean squared error, mean squared? What is mean median mode? I told you before.
Yeah, mean is a ratio of sum of data and total number of data. That is called mean. In simple word, it's also called as average. Like and median means sorting the data and find the middle value from the sorting data.
Acha. Okay.
Yeah, for example, if the numbers are in a jumbled number like 5, 4, 3, 2, 1, like we need to sort it 2, 1, 2, 3, 4, 5. So this is the sorted arrangement, right?
Okay.
So we need to find the middle value of the group.
Okay.
So as you know, there are 5 numbers: 1, 2, 3, 4, 5. So 3 is the middle value. So that's the median of the group data. Mode is a term appearing max time in the data set.
Okay. Let me save this. Yeah. So when you're talking about all those stuffs, okay, means F1 score, precision, recall, support. So when it comes to evaluating the performance of machine learning models in terms of classification, accuracy is just the tip to iceberg. Means in classification tasks, we are using accuracy, precision, recall, F1 score, and support that provide an understanding of the model effectiveness. Okay. When it comes to true positive, what is true positive, false negative, and true negative? What is called true positive means when you have predicted the value is positive and it's actually positive, that is called true positive. What is false positive? When the predicted value is positive but it is false, we found it is as false, then it is called a false positive. What is false negative? What is true negative? False negative is when we have predicted the value is negative but we found it as positive, that is called false negative. Then what is true negative? Means when the predicted value is negative, but and it's actually we found it as negative, that is called true negative. And in terms of precision, precision means it measures the proportion of true positive predictions among all positive predictions made by the model. Means precision formula is true positive upon true positive plus false positive. Means it indicates how many of the predicted positive instances are actually positive. Means a high precision indicates that the model is making few false positive predictions. Then what is recall? Recall means it measures the proportion of true positive predictions. So let me open that. So all are getting it right. No question asked. What is precision, recall, F1 score? And all those stuffs we'll be discussing today. Then in the next class, we'll go for directly to the roadmap itself. Okay. Roadmap, EDA and roadmap to be discussed in the next class. Okay. And project and all the stuffs are pending. I have to complete as soon as possible. So when it comes to precision is nothing but what? What is the formula? TP upon TP plus FP. What is recall? Recall is nothing but true positive, means uh, uh, proportion of true positive predictions among all actual positive instances in the dataset, and is calculated as the sum of ratio of true positive to the sum of true positive and false negative. Means it indicates how many of the actual positive instances in the model is able to correctly identify. Means high recall indicates that the model is capturing most of the positive instances in the data. Means the formula is TP upon TP plus Fn. Okay, false negative. Then what is the F1 score? F1 score is the harmonic mean of precision and recall. Means it provides uh, a single metric that combines both precision and recall, balancing the trade-off between these two. Means that it considers both false positive and false negative, making it a useful metric for imbalanced data set where precision and recall may be skewed. Okay, what is support? Support is nothing but it refers to the number of actual occurrences of the class in the data set, and is the number of instances in each class. And what is the formula for F1 score? F1 score is equal to 2 into precision into recall upon precision plus recall. Getting it, everyone? So when it comes to your uh, all these are we are using for classification model. Okay. Then for regression task, to evaluate the models we are using mean squared error, mean absolute error, root mean squared error, R2 score, all those stuff. Okay. There is one thing. What is ROC core? Who can tell me what is ROC core? Who can tell me in detail? What that is receiver operating characteristics curve. What is that? In classification model we are using. Am I audible to all? Am I audible? Hello? Am I audible?
Yes, sir.
Yes. So tell me, what is ROC curve first? Let me discuss with the ROC curve, then we can discuss more. ROC curve is the graphical representation of a classification model performance at different thresholds. Means it helps to evaluate the trade-off between sensitivity, that is recall, and specificity, that is your. When you're talking about false positive rate, it means in ROC curve, the x-axis represents the ROC curve. The x-axis represents the FPR, false positive rate, that may be calculated as recall. First, FPR is equal to false positive upon false positive plus true negative. There. Your y-axis represents the true positive rate, that is TPR is equal to true positive upon true positive plus false negative. Means each point of the ROC curve represents a different decision thresholds. Means a model with perfect classification has an ROC curve that passes through the top left corner between 0 to 1. And the model that randomly guesses has an ROC curve close to the diagonal, that is y is equal to x line. Then the area under the curve, that is AUC, measures that how well the model separates the classes. AUC curve, remember, means it measures how well the model separates the classes. Means when AUC is equal to 1, that is perfect model. When AUC is 0.5, random guessing, means a bad model, you can say. Okay, this is means highly interpret the ROC curve by AUC value. AUC value near to 1, excellent model. More than 0.8, good model. 7.7 to 0.6, you can fair model, and be lower than 0.5, poor model. Okay, means the ROC curve helps to evaluate the model performance at different thresholds. In the AUC measures the overall ability of the model to discriminate between the class. Means higher AUC value means your better classification model. Getting it? Yes or no? Then when you are talking about yes or no, guys, these are simple stops. You all should remember. You can go for the recording for the further processes. Okay. Okay. When you are talking about the root mean squared error, mean absolute error, and R2 score, and all those stops, means this is precision recall F1 score, ROC score we are using for classification tasks, and for regression evaluation, to evaluate the regression model, we are using mean square, mean absolute error, mean squared error, root mean squared error. What is mean absolute? Mean absolute error is nothing but it is the average absolute difference between the actual and predicted value. Okay, means it is easy to understand and treats all errors equally. Means no square term. What is mean squared error? Mean squared is nothing but means it is the average of square difference between the actual and predicted. Means that penalizes the larger error. So you can see now. Let me open that file. I would have for you. Yeah, can you see my screen now? Huh. Yeah, and I'll let you know firstly when it comes to mean absolute error. Mean absolute error is nothing but what average absolute difference between the actual and predicted value. Means 1 upon n epsilon what actual minus predicted. Okay, then mean absolute error the same, and the square the only actual minus predicted square. So I'll calculate. Suppose you have number of observations. There are 3 observations. The actual value is given 357. The predicted value y dash 258. The error means y minus y dash. Means actual minus predicted. 3 minus 2, 1. 5 minus 5, 0. 7 minus 8, minus 1. Then the squared error, that is y minus y dash square. The square 1, 0, and 1. Then mean squared error, the formula is 1 upon n. This is y minus y dash actual minus predicted square. 1 plus 1 plus 1 upon total number of observations 38, 3. Means 2 by 3 is equal to 0.6. What is mean absolute error when you're talking about that? That is the magnitude of actual minus predicted y minus y dash. So the same 1 plus 1 plus 1 plus 0 plus 0 upon total number of observations 38 is equal to 3. 2 by 3 is equal to 0.6. Okay, means mean absolute mean squared error is the average squared of the squared difference between the actual and predicted. And mean squared error penalizes the larger errors more than smaller ones, and it helps in optimizing the models. Okay, when I'm talking about the next thing, that is root mean squared error. What is root mean squared error? Root mean squared error is the square root of mean squared error that converting the error back to the original error. Means the mean squared error, the root is the root mean squared error. Means that is interpretable in the same unit as the target variable and more sensitive to large error compared to mean absolute error. What is R2 score? R2 score means it measures how well the regression model explains the variance in the target variable. Okay. And a square is we calculated as 1 minus SSRES upon SSTOT. RES means the sum of the squared. SS means sum of square residuals. Okay. Means SS residuals upon sum of square total sum of square. Means this is square and this is total sum of this is square and this y dash can be represented as the total sum of square. Means what are the various characteristics of R2 core? Means R square score. R2 score means the value ranges from 0 to 1, means it's higher. When it will be higher, it will be better. Means R2 score close to 1 indicates a better fit, and if R2 score is less than 0, the model performs worse than a simple mean based model. Okay. Then the next thing that we are using, that is standard deviation. What is standard deviation? Standard deviation measures the dispersion of the data points around the mean. Okay. Okay, means individual data points, mean of the data set, and number of observations should be taken into consideration. Means measures the dispersion of data point around the means how well the data points are spread in the around the mean. This is all about your standard deviation. Getting it? Yes. Standard deviation means it measures the spread of data points around the mean. Getting it? Means higher value indicates the variability and helps to understand the data distributions, and it is used in Z-score and normal distribution analysis. Okay, getting it? Means mean absolute error is a simple but doesn't penalize the large error, and root mean squared error and mean squared error penalize the large error due to more, but these are sensitive to outlier. And R2 score measures the model goodness but doesn't indicate the error size. And standard deviation helps to understanding the data variability, means how well the data is spread around the mean. Getting it, everyone? Yes.
Yes, sir.
So having said that, let's wind up the class for today. And tomorrow or day after tomorrow, we'll be having another class. All of you join, and we'll be discussing the roadmap and further details because we have less time. Okay. Thank you, everyone. Let's wind up the class for today.